you all took 2000. Well, no, that's not true, right? The non-engineers took 2001. The engineers did not take 2001. So what we're going to do is parsing. And remember, I gave you that we did a really quick parsing when we were doing recursion, right? Given this thing, what is our output? Our output is the parse tree. Remember, guys, kind of remember this? If you're an engineer and you didn't learn this, I really do think it's useful in your life to know about context-free grammars. Right, so here's a grammar which says, what is an expression? It's a sum of terms, right? What is a term? It's a product of factors. What is a factor? It's either an integer or it's an expression in brackets, right? So this grammar defines what's a valid expression, right? Everybody kind of buy that, more or less, right? And we gave a recursive algorithm for it, right? Now we have a different grammar, right? So we're going to have different concepts. These are called non-terminals. The terminals are the little letters. The non-terminals are the big letters. And a T, what is a T? Well, if a T is a concept which is an A followed by a B, or it's a C followed by an A, or it's a T followed by a T, right? Now the problem, and you could have much more complicated grammars, but one thing that Chomsky, everybody know Chomsky? You should study Chomsky. One, he was a linguist. He started out as a linguist, and he did lots of work on context-free grammars and on finite automata, and a great deal of what we teach in 2001 was by Chomsky. But why should you study him now is because if you know Bernie Sanders, who's on the left, Chomsky is a few more miles on the left. All right, so it's if you want to read about a really good speaker about why you should be on the left, you should read Noam Chomsky. Right, he's about the same age as Bernie. All right, so we're gonna anyway. One thing Noam says is that you can take your grammar and you can turn it into a grammar where here we have each non-terminal goes to two non-terminals or goes to a single letter, and you can take any grammar and turn it into that form. And then you can imagine here I give you some string, and you can give me a parse tree. Right here, a T goes to a C and an A, right? And what does the C do? The C goes to an A and a C, right? Everybody kind of follow how this parse tree goes, and it all goes down until you get to some string at the bottom, right? Are you following the parse tree? Yeah. All right. So if we tried to do what we did before, right, which was a beautiful algorithm that just flew through in linear time, the problem is that Mr. T doesn't know whether he should call Mr. A or Mr. C or Mr. T, right? That's one problem. Another problem is Mr. T called Mr. T, you'd run forever and you would have a problem, right? So those are two problems. And so we are going to instead do dynamic programming, as you can guess, right? And the dynamic programming algorithm, right? The bird, she's holding one of these solutions for us. And you should already know what question we asked the bird. Is we asked her about the root, right? That's what I told you we're going to ask. We asked her about the root. We know, what do we know? What is our input? It says our start terminal is T, our start non-terminal is T, and we have a string of terminals that we go to. So we know we're going from T to the string, and we ask her what rule do we use first, right? Does that make sense? And then it's natural to ask our friend about the left subtree, and we ask our other friend about the right subtree, right? Everybody get that? Now, what's problem with this is what instance do we give our friend, right? I need to tell this friend to start at T, right? But where does this friend end? Well, it ends at some of this string, right? We don't know how much of the string, right? So what do I give my friend? Well, this is what I want from my friend, right? So what do I ask him? I have to ask him this, right? But how do I, and he gives me that. And so I need to know where to split, right? How am I going to know where to split? The bird. We can ask the bird where to split, right? Because we have a bird. Very good answer, right? So the bird tells me the first rule, and she tells me where to split, right? And then my friend, oh, and how many answers do I have? Well, first rule is however many rules involve T, right? The where to split is the number of characters, or the number of characters plus 1 or something, right? And now, what's the total number of answers? Is it this plus this, or this times this, or the max of these? You have to try all of these. And you have to try all of these. But more, you have to try all combinations of these. So we're multiplying them, right? We're multiplying them, right? Does that make sense? We ask our one friend, gives us that. Our other friend gives us that. We combine them to get that. And we go home, right? So here's the code. It's looping over all subinstances. Right here, it's looping over all substrings. Our subinstances are from every, oh, here at Mary. Anyway, here's the code, and we can go through it, but here we go a little bit further. What is their set of subinstances, right? We say, well, here my left friend is given that, right? And then he gets something, and my right, his right friend is given that, right? So all my subinstances are, I have to start from every possible start symbol, right, to every substring. I have to go from some I to some J, right? So the number of subinstances is the number of non-terminals, right? Because the number of these times n squared, right? Because number of i's and the number of j's, right? And so we're going to get a big table here, right? Here's the table. See, I did this at one. I made this table probably 25 years ago. Right here, we got i's and we got j's and we got non-terminals, right? And for this ij entry, somehow when we split it, somehow you go like this, right? This is my friend and my, right? Because this guy's here's different k's. This is going to move this way, and this one's going to move this way. Anyway, you can play with that and see it. Doesn't really matter. So the running time, right, is the number of subinstances was the number of non-terminals times n squared. Number of bird answers is n, right? So we get n cubed times the number of subinstances, times the number of non-terminals, right? Everybody good? So n cubed is clearly worse than our previous algorithm, or our linear, but it works for these weird grammars. Everybody good? We got more minutes? 20 more minutes. We're just whipping through this.